In the previous video, I have had a brief introduction of the new software nuVML Virtual Modeling Lab and showed you how to install the software and how to activate the license and the basic manuals, and showed you the basic functionalities, and also designed a very first simulation and showed you how to start and stop the simulation. In this video, I'm going to go a little deeper into a more complex network simulation and demonstrate how exactly VML can benefit in terms of network visualization. To start, we first start the application. So after the application is started, make sure you connect to your VIRL backend server. In my case, it is 172.30.30.80. The VIRL server I'm running on is the latest version 1.2.83. I designed a 6-node network topology. It's basically 6 iOS routers connect together and already configured using the Auto Network and Net Connect kit. And I'm going to start the simulation. And we will see the nodes are starting up. To save time, I'm going to pause the video and restart when all the nodes are running. Now the routers are coming up. As you can see on the right side, it all becomes reachable. And you may see the routing protocols, OSPF, are trying to converge. The RP tables are trying to get MAC address. We can zoom in, change the view, rotate. Okay, it seems all the routers are up. To log in one of the routers, there are 2 ways to connect to the console. First one is you can click on the router and go to console. As you can see, when you click on the router, it shows you all the interfaces and how they're connected. The other way to connect to a router is going to list, right click on, and telnet to console port. The default password is Cisco. It's the IP address assigned. The first test I want to show you is doing some ping test from router 1 to router 5, for example. We can get in router 5 to get the IP address. As you can see, router 5 has a loopback IP of 192.168.0.5, and router 1 has 192.168.1.1. I'm going to generate some ping traffic to router 5 from router 1. Repeat 500 times. The purple traffic is the ICMP traffic. Let me try again. It's not instantaneously. It has a 5 to 10 seconds of delay before it shows on the 3D view. As you can see, the ICMP traffic is going across through router 3. Now here you can also see the packet capture window and list all the sessions that's being captured. By default, packet capture started immediately after the simulation starts, and as the buffer fills, it replaces the oldest data. So we get into one of the routers, say router 5, view traffic. As you can see, this is OSPF broadcast IP 224.0.0.5. If you click on it, you can see the details. Router 5, this is router 5's gigabit 0/1. So if I try to ping this interface 10.0.0.38, repeat 1000 times. And traffic will update accordingly. As you can see, all the ICMP traffic is showing up. It's coming from router 1 and pinging router 5. The source IP is 10.0.0.5, which is the interface of router 1 outside facing. 10.0.0.38 is gig 0/1 on router 5. The next feature I'm going to show you is traceroute. In traceroute view, here I'm going to select router 1 interface 0/1 facing router 5. First interface 0/1 and can start the traceroute. This is the traceroute traffic. As you can see, it's multi-path. It can coming from through router 3 or through router 2 to router 4 to router 5. And the traceroute path, the most optimal path is shown in this attribute view. If you want to see what is connected, the interface between two routers, you can select the interface and right click on, you see the information about this interface on both sides. If you select this, right click on an interface. We also have slice view. A slice view is a 3D visualization of the interface. We will have visibility of what routing protocols and virtual interfaces is running inside the interface. As you can see on the left side, it is router 1 with IP address 10.0.0.5. The first interface is this yellow-green interface and with an IP of 10.0.0.5. And this is the second interface on the router with IP address 10.0.0.9. Similarly, that's the third interface. And they're color-coded in different colors. On the right side is the same interface connected to the other end, which is router 5. The first interface has an IP of 6. It's router 2. It's directly connected. And the interface has different IPs with different views. So this is a very useful demonstration of what's inside a interface. When you have multiple physical interfaces and the virtual interfaces, it will show you every interface inside the physical interface between routers and give you it much easier to understand. The other feature I want to show you is show protocols in 3D view. Select one of the routers, right click on it, and show protocols. Since it's a very simple simulation, we don't have a lot of interface and routing protocols or VLANs running on it. It's simply showing 3 layers with different color-coded view. You may change the size, the direction. It becomes very useful when there's multiple routing protocols are running on it, and with numerous of logical interfaces. Okay, it concludes today's video demonstration. To save this topology, you can go to Save VIRL. It's a standard topology file you can use next time. To stop the simulation, you can highlight the simulation and right-click Stop Simulation.